Hi, I'm back. Yes, the COVID hasn't got me. Now, I've kept delaying making another video until I thought I had something finished, but that's probably never going to happen. So I thought I was at a point where there is something I can show now with progress on the SpotCorgi project. Now, the most obvious thing you'll see immediately is that the body has undergone some changes. SpotCorgi now has a head and a face and new legs. Now the face is obviously very similar to the original Spot and the Spot Micro. Let's just call it convergent evolution. It's the best way to house the ultrasonic sensors, etc. Spot also has the black dot in the center of the face, use a ESP32 camera for video, and also extra ultrasonic sensors underneath to detect ground height. I'll explain what they're for in a second. Now, getting back to the changes, the head is in progress. It's sort of working, but doesn't actually have any software per se for controlling Spot. I've got as far as having so it'll track a moving object and plot the position on the screen, but that is still waiting to be integrated into SpotCorgi software. The other obvious change on the body are the new legs. Now, I've simplified the leg design a great deal. I found the previous legs I had took ages to print, plus there were left and right differences, etc. So I've greatly simplified that so that the new leg design essentially consists of the three big parts on the left, repeated as needed, and the sundry bobbins and whatever on the right, which you print for each side. So essentially you print 16 of the bit on the top left, 8 of the bit on the bottom left, and 4 of the leg bit in the middle, and then the sundry bits on the right there. You'll notice Spot on the leg at the back. You'll also see how he has a little paw pad to improve traction. Other than that, the other change, the chassis itself is essentially unchanged except for I have removed the individual batteries. Now this looks very messy because I've still got to tidy up the wiring. Removed the individual batteries and made space for a homemade battery pack, which is 4 18650 batteries wired up in series and parallel, as I've explained previously, to give me the rated 7.4 volts to run the model. On that as well, I've also finished my power supply, which I've been using to run the model while I'm testing. And that is one of those things where once you make it, you wonder how you did without it. That's fully adjustable on voltage and ampage and has various outputs, etc. So I've been running that at 7.5 volts for testing, and everything seems quite happy with that voltage, so I'm optimistic that the batteries will work too. The other thing I've been doing is working on software. Now this has actually involved getting out a pencil and paper, and you know it's getting serious when you revert to pencil and paper. So I've been doing all these calculations on how to calculate leg angles on the fly. The previous model, you essentially put in some parameters and it created a table of leg positions, which it then read to do the move, which is not optimum, obviously, if you want to make changes on the fly. So I decided I needed to be able to calculate leg positions and angles on the fly. So that's where all this came in. All of that up there is wrong, except for the bit at the sort of the top rightish there, which says theta equals a cos step over 100. And that's the key to the whole formula. Now it's simple enough, but then because the Arduino requires radians for trigonometric calculations, the servos need PWM measures for their position, and being a human being, I'm more comfortable working with degrees, or being an uneducated human being maybe. So it took a bit of time. I had to go back to my high school trigonometry, which has been a very, very long time ago. But in the end, I figured it out. The way I characterized it to my son was, how tall a pile of bananas do I need so that at 3 p.m. it casts a shadow 5 potatoes long, because you're converting degrees to radians, radians to PWM, and then doing trigonometric calculations on them. But anyhow, the end result has been, at the end of my first week of lockdown, I've managed to produce a little gem of 23 lines of code, which will calculate the movement of the upper leg in this little very basic graphic here. Sorry for the shadows. The upper leg, I've figured out, only looks after movement on the x-axis. I was trying to calculate both at once and it gets too complicated. So I've said, okay, the upper leg will look after the x coordinate, the lower leg will look after the y coordinate. So that makes things a lot simpler. So I managed to come up with a bit of code where, for a given movement on the x-axis, what are the required angle movements of the upper leg? So I can put in a starting position and a step size, and it'll just calculate the angles and do the move. Now obviously that makes it much easier on the fly, where you can just plug numbers into the function and it will calculate those values on the fly. I've done the x-axis. I've got to get back to do the y-axis for the lower leg, which is a bit complicated because whereas the x-axis is reference to the horizontal body, the y-axis, the lower leg, is reference to the angle of the upper leg, so it needs a bit more calculation. But that's where it's up to. I'm sorry it's not actually moving around or doing anything, but as I say, I thought I'd show some progress anyway, rather than stalling making a video until everything's perfectly finished, which it will never be. So I'm not sure whether I've forgotten anything, but as usual, any comments or suggestions are more than welcome, and I'll see you later. Bye.